Welcome back, everyone. Good afternoon, all. Now we have our second section, and this will be a machine learning hands-on session in Python. And this will be handled by our Diti ma'am. Diti ma'am, welcome back.
Thank you, Namita. Start. Okay, so though there are many languages are Veka and all, Python is gaining popularity because of its rich library and readability. It's very easy to run a machine learning algorithm with few lines of code. And the platform independency, the flexibility, and there are so much of visualization, different kinds of visualization that Python provides, and which is one of the main reasons why Python has become a popular machine learning tool. So what I will discuss today is a hands-on with Google Colab, but just me know if anybody has worked with Google Colab or Jupyter Notebook. So for running the machine learning task, we need Python installed and Anaconda Navigator. And if you install these, you'll get something called a Jupyter Notebook. Okay, Jupyter Notebook, or there are different other versions also. So apart from doing in Notepad and executing in command line, you can have a interface wherein you can have text documentation added in the form of cells as well as code running there, and after the code you'll get the result. You can save those results also. So that kind of interface is called a notebook, a Python notebook. I think some of you may be aware of that. So without going into those installation and all, what I think is we'll do in Google Colab. So it is a online tool, and it supports GPU for free. So it is called as Google Collaboratory, and it is a development tool. So you don't have to install this Anaconda and all. So there are so many packages that you have to install if you go for offline installation of Python and Anaconda. So to avoid all those hassles, we'll just for beginners we can do in this Google Colab. So it's an online tool, and it supports GPU for free. And apart from that, we can just like you share your Google Docs or Google spreadsheets, you can share these notebooks. You can the notebooks will be saved in your Google Drive. So all you need is to just sign in into the Colab using your Gmail account. You'll get a Jupyter notebook there. You can code, you can run Python codes, and you can have the results near the codes itself, and you can save that notebook. The notebook gets saved automatically into your drive and can be accessed anywhere. You can share the notebooks, you can upload the notebooks in your drive, and so on. And also you can select data from your local drive or from your Google Drive. If you have so much of data, it's better to, like when we deal with images and all, the data has to be first loaded into Google Drive. Then the drive can be mounted, and the data can be accessed in this development environment. So that is also possible. Also we can extract data from Kaggle, import from there. Then all Python libraries can also be integrated. And GPU is also available, because when we run huge amount of data, it may take it may take even 2 days to complete the training process. So you need GPU to run such huge amount of data. And this GPU service is provided free by this collab. So these are the capabilities of collab. Um, just you have to log in online to Google Colab and you can start doing programs. And these are the Python libraries we will see today. Important libraries: NumPy, Pandas, sklearn, and Matplotlib. I'm not sure if you are familiar about Python language. Most of you must be knowing, but even you don't have knowledge about Python, it is easy to get to know what are things are needed to run a machine learning program. So that's what we'll see today. And this NumPy is the library for scientific computing in Python. It gives you access to array object, and you can work with arrays. So that's the purpose of NumPy library. It is used in for running this machine learning task. The second one is the Pandas library. So Pandas is for working with data sets. So data sets can be saved in Excel files in the form of CSV format, comma separated value format. So those data can be loaded into the Colab environment, and we can load it into this data frames, what you call as a data frame. So this data frame is nothing but a two-dimensional data structure. So it can be considered like a table with rows and columns. So if you have attributes of persons having a disease, the attributes will be each person can be considered as a row, and each of the column will represent the attributes. So a tabular structure is what a data frame is. And this Pandas, this data frame is available within the Pandas library. So data manipulation is what Pandas is used for. Also, we have different functions for data pre-processing, exploring, and all are provided by this Pandas library. Then sklearn is the scikit-learn, which is the library which includes the machine learning algorithms. All the machine learning algorithm implementations are available in the sklearn. All you have to do is just call the functions and pass your data and use appropriate functions to run the algorithm. And you can get the accuracy score and all. So that's the package library for implementation of machine learning algorithms. Then last is the Matplotlib. So this is the plotting library, graph plotting library. So you can have visualization in the form of bar charts, scatter plot, heat map, and all. So there is a submodule called PyPlot, and this PyPlot helps to plot such graphical representation of data. So these are the important libraries that are needed to access or run machine learning projects. So we'll move on to the demo session. I think you can do along with me. I'll share the dataset in the link for dataset in the chat box, and also the link for this collab to access the collab. collab.research.google.com. Please go to this link and sign in with your Gmail account. And this is the drive for datasets. You can download this online also. These are basic datasets that are used for running basic machine learning algorithms. So I have put it in drive and shared the drive folder. You can go to the drive link and download those datasets. Please let me know once you have done this. Just download the datasets and save it in your local drive. And when you sign into this Google Colab, you'll get an interface like this. This is what you call Jupyter Notebook. So take File and New Notebook. Also, the link to the notebook I have shared is also shared in the chat box. So just open a new notebook. When you open a new notebook, you will have, if you want to insert a code, you can click on code. And if you want to add some text as documentation, you can click text. So this is like, you can have so many cells separated. So a piece of code or some set of documents can be added in cells. So this is how a notebook will look like. If you install Anaconda distribution and install Python, you will get a Jupyter notebook like this. That is what this Colab also provides, free of cost and the access to GPU. Just let me know if you are able to access all these. Okay. Okay, so first, hope you have downloaded the data sets. First is the iris data set. So just open a new notebook, and whenever I explain each of the data set and some code, you can paste this code from this notebook and try running in your own notebook. Okay, please don't run the code I have given here. Just copy each cell and paste it in your own notebook. Okay. So when you open a new notebook, you can have as many sections you want. If you click a code, you can paste Python code here. And if you want to have some documentation, then you can click text and you can add this as add some text here. Okay. So that's how the notebook will interface will look like. You can have a documentation as well as codes in a single interface. So this is just empty cell I have created. Let me just delete that. So if you, so this is just text which I have given for describing the data set that we are considering now. The iris data set. First is the iris data set. So it is a benchmark data set that beginners start with when they take up machine learning implementation. It's a very small size data set, and the classification, it is a data set for classification task, and there are 150 instances in this data set, and there are 5 features, that is 4 features and 1 class attribute. So it is a task for classifying the iris plant based on these features: sepal length, sepal width, petal length and petal width. So based on the characteristics of flowers, the different flowers belonging to this iris can be classified into different species. So one is the Iris setosa, second is the versicolor, and third is the virginica. So these are the three class labels, and these are the attributes. So altogether we have 5 attributes. Four are the 4 describing the features, and fifth one is the category to which each flower belongs to. So we have details of 150 plants. Okay, so not plant, 150 flowers, and each of the flowers, these details will form one row. So you can just open that CSV file and see the data set. So classifying flowers based on these attributes, that is what this data set is meant for. And I think you have downloaded the data set and stored in your local drive. Now, if you want to access the database data set into your Jupyter notebook, you can write this code from google.colab import files. And uploaded equal to files.upload. And if you run this code, you'll get a upload widget available here. You'll have an option to choose file. Just click on that, then you'll be able to select the file from your machine. Okay, so this is how you can import data from your local machine. Please don't run this code, okay? Don't run this notebook that I have shared in the link. Just copy the code and paste in your own notebook and try running. So this is an online tool. Each time if you want to run some algorithm, you have to load the data into the environment. So now I have saved this file into this environment and run this code. So at any point of time, if you want to rerun the rest of the code, the data will not be saved there. You have to again choose the file from the machine and save it in this environment. This is how you can import file from file stored in your local drive using the upload method. Okay, okay. Before that, I'll tell you one thing more. So I told you this collab gives you access to GPU free, of course. So if you want to run computationally intensive task, or if you have so much of data, you can use the accelerator, GPU accelerator of this collab that is provided by Google. So the GPU is with the Google, and we will be running our code in the GPU cloud. Okay, cloud service provided by GPU. So to enable that option, you have this runtime option over here. In runtime, select change runtime type. Here you will have the option to set hardware accelerator, GPU or TPU. So this is not needed now because we are checking with just a small data set. You don't have to give any hardware accelerator because this will take just seconds to run. But I don't know, there were problems when I was sharing this collab in Google Meet, there were disconnection problems. So that's why I'm not running it live now. I'll try running now. Sometimes Chrome gets crashed and there are disconnectivity issues also. So please try running and let me know if there are any problems. So this is how you can access the GPU. You can select either GPU, and then you can click save. That means after that, when you run your code, it will be running in the GPU provided by Google. But for the time being, we don't need that. We can have it as none itself. So this is the feature provided by Colab. We can run our code in cloud. So are you able to load the file into the notebook? Just let me know. Yeah, Iris you can download. Yeah, okay. So then the file will be saved into this will be available in the notebook. Now what you can do is you have to read the file. Just that the file becomes now available in this environment. Now we have to read the file and do some operations in the file. So to load the file, the function is read CSV, and this read CSV function is available in the pandas library. So pandas is a library for loading and doing some exploratory analysis tasks. So you have to import this library using the statement from pandas as a PD. So this is an alias that you can give. This you can give as any name to your choice. Import pandas as PD, and using this alias you can access the function, that is read underscore CSV, and you can give the file name here. So this file name is a file name that you get here, or the name with which you have saved it. There are two methods of importing modules. One method is from google.colab import files. This is also possible, or from pandas. Import pandas SP. This is also possible. This can be written as import google.colab.files. So these are sub-modules. Colab is a sub-module and package is again a sub-module. So once you read a CSV file, it will be stored in a data frame. So this data frame is nothing but a tabular structure which will have the details, which will store the data, that is the attributes as columns, and each row will be the data instances. And this describe function will give some statistical information about the data set. So these are the four attributes: sepal length, sepal width, petal length, and petal width. The count is the number of instances having values for this field. So there is no missing values. So there are 150 instances of each of them. That's why the first count is 150. Then mean value of sepal length, sepal width, and so on. So mean value of all attributes. Then the standard deviation, minimum value, 25%, 50%, 75%, maximum value. All these summary you'll get using this describe function. This notebook is available, right? I've shared in the chat box. Okay. You can copy the code from this notebook and paste it in your own notebook and try running. Okay. So this is the first thing that you will do when you get a data set. You can otherwise just open the data set and see there will be 150 data instances having values for these attributes, and the last column will be the class attribute. Then dataset.shape will give the dimension, that is we have 150 rows and 5 columns. So that is the dimension of the dataset, that is the shape. So print dataset.shape will give the number of instances and number of columns, that is the number of attributes. Then dataset.head of 20. You want to get the first 20 rows of data. You can give like this, head of 20. So this is same as what you have in the file, the details, the attribute values of the first 20 instances. So each of these is a data point, that is details of a single flower. So first 20 will be displayed. So if you give the number of rows here, that many number of rows will be retrieved and will be displayed. So this notebook, since you have signed up with your Google account, this will be saved automatically and also saved to your drive. So anytime you can log in and you can see this code. This output also will be saved like this, but next time when you want to make changes, you have to start from this code. You have to import the file again and then run the code once more. I hope you are doing now. Do you face any difficulty? It is sometimes it may take some time because you are connected over Google Meet. Sometimes it may take some time, face some delay in running the code, but otherwise small data sets run pretty fast when you don't have other tabs opened or Meet opened. Please let me know if you are done. Okay. So next is some visualization, that is if you want to know the distribution of each attribute. So we have total 5 attributes. The distribution of the number of instances in each range of values will be plotted as a histogram. So you can obtain a histogram plot using this method hist. So this function is available in the pyplot subpackage. So you can import pyplot from matplotlib. You can write in 2 ways: from matplotlib import pyplot or import matplotlib.pyplot. Both are the same. Pyplot is a sub-module inside the matplotlib. So this is the package or library for visualization. So dataset.histogram will plot all attributes in the form of histogram. So this is a representation of how many instances are having this value. Okay. Okay. Now we'll see another data set, the diabetes data set. You can do any run classification algorithm on this data set. I'll do that with the next data set, that is the diabetes, because it has got some more attributes and we may have to do some pre-processing task. So just download the second data set, also diabetes data set, PIMA Indian diabetes data set, that is the file name. So this data set consists of 768 details of patients, okay, women patients with 8 input variables and 1 output variable. So the prediction is to find out whether a person is diabetic or not. So details of only women persons are there. So the first attribute is number of times pregnant. Second is plasma glucose concentration. Then blood pressure, skin fold thickness, and so on. Insulin, BMI, age is an attribute. So 8 attributes and the last attribute is 0 or 1. 1 means diabetic, 0 means non-diabetic. Again, you can upload the file into the Colab using the upload function. When you run this code, you'll get the option to choose file. Choose the file, then it will be available online. The describe function will give the details, summary information. Then head will display the first rows, how many rows you need. You can specify it there and you can retrieve so many rows of the data set. Now you can check for the missing details in your data set. That is, if any attributes has missing values that you can find out. So here we have altogether 8 attributes, and the first attribute is number of times pregnant. So it can be 0. So a 0 value is admissible in that attribute. In all other attributes, a 0 means there is no value there. There's the attribute value is missing. So we have to find the number of data for which there is a missing attribute. So you can check the attribute index. That is first 0th column is the number of times pregnant, that you don't have to check. From 1 to 5, you can check, and you can check whether check the count. That is number of attributes for which there is missing attribute using the sum function. So in this data set, only 1 to 5 attributes 1 to 5 has missing values. That's why I have given it like that. If you even if you give 1 to 8, that's fine, because when you deal with a new data set, you will not be able to find out whether there are missing values in any of the attributes. So just check on the attribute what it represents. If zeros are admissible, just leave out that and consider all other attributes. So you can say consider from 1 to 8 and find out the total number of instances having 0 in that particular column using this sum function. So data set of 1 will retrieve the first column and check whether there is a missing value and take a count of each of them and return that. Similarly, each of the attributes 0 values, the number of 0 values can be aggregated just by using this method, the sum method. So dataset again is a frame that is in the tabular format. That is why you can access it using this index, that is the column number. So when you do this, you'll get the result like this. In attribute 1, there are 5 missing values, 2, 35, 3, 227, 4, 374, and 5, 11. Please let me know if you are done. Okay. So now there are certain classifiers. For some classifiers, we'll get the output correctly even if you have missing values. But some classifiers doesn't permit missing values at all. So let's see what happens with the missing values. We can try to mark or replace the missing values with NaN. So NaN is not a number, that is a constant. You can replace the 0 with NaN. So we have missing values from 1 to 5. So for 1 to 5, we can replace data set of 1 to 5 dot replace 0 comma NaN. We'll replace the value of 0 with NaN. And after this, if you check is null dot sum, it will count the number of NaNs and retrieve the null values. So the first attribute, we have many instances. We may have several instances having 0 value, so that won't be counted. We'll just count the NaN values from 1 to 5, and 6, 7, 8 there are no values for 0. That's why it is 0 there. And if you, after replacing this, if you print dataset.head of 20, you can see the 0 values being replaced by NaN. So we have seen imputation, that is this NaN values, that is the missing values can be replaced with some value, that is mean or median or K nearest neighbor. So to fill the NaN values, that is replace the NaN values with some other value, the function is fill Na. So fill Na of dataset dot mean comma in place equal to true will replace the NaN values with the average of the attribute values. So after you replace the null values, if you check is null, you can see that there are no more null values and you can see the values being replaced. There are no more NaN values in the dataset. Now you can try running this K nearest neighbor algorithm. So as I've told, sklearn, you have to import the sklearn library for implementing or accessing the classifier functions. So sklearn.neighbors, this is the package, the submodule in which KNearest Neighbor classifier is available. So all these are built-in package names. So we have to give all these like this itself, sklearn.neighbors import KNearest Neighbor classifier. Then that's for accessing the classifier. Then if you want to split the data into training set and test set, you have to import it from the model selection. sklearn.model selection. Import this function train test split. Then the classification report are available in sklearn.metrics. So just load the data set and store it in an array. And you have to split the data into training set and testing set. Before that, you have to separate out into two arrays. That is, X will have the attributes and Y should have only the class label. So 0 to 7 will be the attributes. So 0 to 8 excluding 8 will be stored in X. And Y is the last class attribute. So it will be 8. So this is the data and this is the label. And now we have to split into train set and test set. So for data and label, you should have, you should split it into train set and test set. So X train, X test, similarly Y train, Y test. So data will be divided into these frames using the train test split. It's x comma y, and test size you have to specify. I have given here 0.20, that is 20%. 20% will be selected as test and 80% as training set. So 80% of data, that is the attributes, will be in X-train, then 20% will be in X-test. Similarly, the class attributes will be in Y-train, and the test set the class label will be in Y-test. This is how you have to divide the data. You have to separate out the attributes into one frame and the class attribute in another frame. Again, both of them you have to divide into test and train set. Then you can call the function KNearest Classifier, KNeighbors Classifier, and number of neighbors is n underscore neighbor. So this is the argument for KNeighbors Classifier, n underscore neighbor. Okay, so this is a variable name. You can give the number of neighbors here equal to 4 or 3 or anything. Now to train the model, the function is fit classifier.fit xtrain and ytrain. So we'll provide only training data. So xtrain, that is the attributes will be there in xtrain, and the class label of those attributes or those instances will be in ytrain. So this is the training data and corresponding label. So this is all you need to supply for the fit function. And predict function will predict the label of xtest. Classifier.predict the test data you can give as argument for the predict function. And accuracy, so y test will now, so y prediction will have the class labels of the test data that you have given. That is 20% of test data, those class labels will be there in the y predict. Now we have to compare it with the y test. That is the actual label. So this is the actual label, this is the predicted label. So you can compute the accuracy using accuracy score of y test, the actual label and the predicted label that you have retrieved here. It will give the accuracy of the model. Is it clear? See, metrics, it is, what is the use of metrics? So metrics is the submodule from which you can retrieve the classification report. So confusion metrics, classification report, everything is there in this matrix. The performance measures can be accessed from this submodule. That's why you have to import these. And try printing the confusion matrix also. So if you run this code, every time a different split will be considered. So you may get a slightly different accuracy in different runs. Train test split will divide the data randomly, takes some say 20% for test set and remaining 80 for train, and it will change in each run. Dhanya Naren, yes, please go ahead. So these are the functions that you will need to use to run a classifier. You have to know the function. And this train test split, this function is the same. You have to know whichever classifier you're using. And the argument may differ based on the classifier you're using. Then fit function you have to use, and then you can use the predict function to get the prediction. And print the accuracy score, different metrics you can print, confusion metrics also you can display. This is how you can run a classifier. I hope it's clear. You can try running before and after replacing the data with missing values. So we have seen already how to replace missing values with inane and then fill it with mean value. So just add this code and try running. And also if you change the number of neighbors, there can be changes in the accuracy also. Okay. So I hope you have done till this. So, I'll show you one more case where we have a linear discriminant analysis. So this is another classifier. So if you try to run this without replacing the inane values, you'll get an error. So this algorithm doesn't permit this null values. So only after you replace the data set with null values, you'll be able to run the algorithm. So if you want to entirely drop a data which is having a null value, you can use the function drop any. Simply remove the instance from the data set where there is a null value. So after removing 392, only 392 instances are there out of the 768 total instance. So this is not an advisable method when there are so many missing values in the data set. So once you have removed the just replace the zeros with an n and replace with some mean value. If you try running, the accuracy will be increased. So here the cross validation has been used, CVC cross validation. So number of split you can set and shuffle equal to true you can set. These are the parameters of the cross validation method. And so this will run the algorithm many times and give the mean result. Accuracy will be the mean of different runs of the experiments. So again for this you have to understand check the syntax, the parameters of all the methods. This cross validation score, this is again another method, cross val score. Here you have to give the parameter as model, that is linear discriminant analysis. So there are slight changes in calling the methods. There is no parameter for this linear discriminant analysis here, but you can specify the x and y here. And you're not splitting into train and test set as we have seen in the last one. The last one we have splitted into 2080 data set, but here we are splitting, we are specifying the number of splits here. So the entire data will be shuffled and splitted into 3 folds, and 3 times experiments will be done, and the mean result will be displayed. So this is another notebook. I'll share this also. It's not there in the previous one. In the other one it is only KNN is there. So that's about dealing with missing values and imputing. There are other imputing methods also, simple imputer, KNN imputer and all. Now there is one more data set in the drive, that is the salary data set. If you are using the train test split, you'll have to run it say 10 times and take the average accuracy. If you are doing cross validation, the number of experiments will be set in the code itself and number of splits will be taken randomly and you'll get the average result. That's how you have to do experiments. Because if you do a train test split just once, it will just give the result with just one random split. So in another run, the accuracy can be different. There won't be very much difference, but still there can be a slight difference in different runs. So we have to take the average of the accuracy scores. I hope you have done till this. Can we move to the next data set? Okay. So next one is the salary data set. So which is for running regression task. And you can import the file, and these are the details in this data set: years of experience and salary. So if you print the first few instances, it will give the details like this. And one thing you can do is you can categorize, you can add bin labels, that is categorize the salary into different bins. So you can specify the ranges over here in an array. So 0 to 40,000 low, 40,000 to 60,000 medium, 60 to 1 lakh standard, 1 lakh to 130 high. You can give labels also as an array. The cut function will create a new label, that is new attribute called income bin with these bins and labels. So you'll get an extra attribute added as income bin, wherein each of the salary will be mapped to the corresponding bin. So this is again a pre-processing task. Binning can be done to find out the range or category to which each data belongs to. And once you have done this, you can use the counts function to count the number of persons belonging to each of these categories. So this is a small data set that with just details of 30 persons. One more category has been added corresponding to the bin. The bin labels can also be added. If you give labels equal to labels, it will add the label as one more attribute. So dataset is the data frame. So database of this name will create one more attribute to the end, and it will categorize it. Will give the category to which the income bin belongs to. This you can plot as a bar chart. That is categories dot values count dot plot kind equal to bar. We'll plot a bar chart. 11 people have standard, then 8 has high, 8 medium, and 3 low. I think the screen was not shared. So this is the salary data set. A scatter plot will give the plot of these two variables, that is years of experience and salary, and have an XY plot. That is what this scatter plot is. The function is scatter. You can specify what you want in the x-axis and y-axis. Also the label. So by looking into these plots, you'll have an idea of whether you can whether there is a linear dependence between the variables and you can use a linear regression or not. So this is the purpose of uh, visualizing using different graphs. Bar chart will give a summary of how many people have so and so range of salaries. And this gives a relation that you can definitely fit a line for making a prediction in future. If given the number of years of experience, what would be the salary? So if you are using Anaconda installation and you have installed Python, and if you are running in your local Jupyter notebook, you cannot run like this. You have to import packages. You have to install the packages, then only you will be able to import these. It is just because this is the online notebook, you are able to import like this. Otherwise, you have to install these packages. Then only it will be available in your code. Hope you have done till this. Any clarifications? There are a lot of visualization other than this. There is some other package called Seaburn, which also gives so many plotting. I have just mentioned about Matplotlib only. There are other libraries also you can import and do visualization. Next is some transformation, that is we have seen uh, scaling, that is converting the attribute values into some particular range. So min-max scaler is a min-max normalization is a method which will map your data into data between min and max value. You can specify the minimum and maximum value, that is 0 and 1 or any range of values. So your data will be scaled in this range. So here the PMI Indian diabetes dataset has been taken, and all the attributes have been scaled to this range 0 and 1. So you can see the values being mapped to the range between 0 and 1. So min-max scaler is available in the pre-processing submodule in the scaler. So there are other normalization also, standard scaler, then normalizer for Z score normalization. Then there is, hope you are done till now. You are able to run the code, right? And now one more type of pre-processing or encoding is the ordinal encoding. That is, if you want to, if you have some categorical attributes, okay? If you want to have convert them into numerical numbers, that is each category can be assigned a different number, that serves the same purpose. There is no meaning in retaining the categorical attributes. If some algorithms can work only on numerical data, you may have to transform the categorical attributes into numerical ones. So that's the purpose of ordinal encoder. So here, and this I haven't shown it with the data set. We have created an array. So with the labels red, green and blue. So I want to have category labels, that is numbers assigned for these labels. Okay. So for that, the ordinal encoder function can be used, and the fit transform will um, make the convert the ordinal, that is the category of these labels, and convert them into numbers. So how this is done is the red, blue, green. This will be sorted in alphabetical order. So B will be assigned, blue will be assigned category 0, then green, and then red. So 2 will be the label of red, 1 will be the label of green, and 0 will be the label of blue. So this is called ordinal encoding. Converting categorical data into numerical data. That is giving, just assigning some numbers sequentially from 0 to, say if you have 5 categories, 0 to 4 will be assigned. Then another encoding is one-hot encoding. So again, as array will convert, it's a function to convert whatever you give within as parameters into an array. So one-hot encoder will have as many bits as you have as categories. So we have 3 elements here. So 3 bits will be used to represent each of them. So starting from the first alphabet, that is blue, green, red, this order it will be taken. So for red, the last bit will be having 1. For blue, first one will be 1. For green, second one will be 1. So 0, 0, 1 will represent red, 0, 1, 0 will be green, and 1, 0, 0 will be blue. This is called one-hot encoding. Another thing is you can convert range of values into, say, 2 distinct classes. If you want to say just categorize all the attribute values into just 2 categories based on some range, you can use binarizer. So suppose I have values in the array 10, 20. So my runtime has got disconnected. I'll try to reconnect it now. Okay, so these are the values. So until 30, we want to assign as 0, and above 30 should be assigned as 1. In that case, you can use the binarizer, and the limit can be set as parameter. So whatever values less than or equal to 30 will be assigned as value 0, and above that will be assigned as value 1. So for an attribute value, if you want to have them into, say, 2 categories, you can use these type of types of pre-processing. So all values will be assigned as one category. That is, binarizer will convert into just 2 categories, 0 and 1, based on the value you specify. So that's all. So these are some of the basic pre-processing things that you can done with the data, and you can try running other algorithms also. So each algorithm will have some parameters to set. You should have an idea about the optimization function and the parameters. For k-means, you have to specify just the number of clusters. The initial centroids will be picked up by the algorithm itself, and a different run will be giving slightly different results based on the initial centroids picked. You have to anyways specify the number of clusters to be found. That is, k should be specified for k-means algorithm. So if you have any doubts in this, you can ask now. The notebooks are already shared. You can try running this code. There are so many other libraries, KNearest, PyTorch and all, for TensorFlow and all, for the neural network. All we have to do is check for the libraries that are needed and the functions and the parameters. So you have to have a theory, background understanding of how the algorithm works, how to set the parameters. Then you will be able to run all algorithms with few lines of code. So CSV files you can upload into a Colab notebook like this just by running the upload function, and you can browse the file from your local drive. But if you have, if you want to load, say, so many images, if you have, let's say, a lot of images, and each image will be saved as a file, and it has to be stored in separate folders. Each category of images should be saved in different folders, and the label of each of the image should be stored in a separate file. All these are needed to run that, and these have to be uploaded in your Google Drive, and the drive can be mounted, and you can make the data available in the Colab notebook. But when working with images, depending on the number of images, it may take, the training time will be high. So my students have done a project on the plant disease detection dataset. Apart from the public dataset available in the Kaggle repository, that is, from the leaf images, we can identify whether what kind of disease it is suffering from. So that, such a data set is available. Apart from that, they collected some images, real time, some 700 images after going to a farm, and they added that data set also to this data set, and they run that code in Colab, and it took 40 minutes to train the whole model. That's because this code is running in Colab. But when you run in normal CPU, it will take a day or two. So this collab is available most of the time, but you may have to run it so many times because there are frequent disconnection issues with this when you run it for a long time. Are there any questions? Namita Miss,
If you have any question, you can ask now.
thank you so much. It's very difficult to put theory and hands-on in just 1 or 2 hours. So what I have covered is just basics because explanation of each of the algorithm and the mathematical model and the optimizer will take 1 hour each, at least 1 hour each for each of the algorithm. And the data sets that I have given are very simple, very basic data sets. You can check out in Kaggle for large data sets and try running these algorithms. It's not that easy to set the parameters and get good results. You may have to try doing so many pre-processing and trying out different parameters. That's the challenge. Otherwise, the implementation of all algorithms require just few lines of code. But that's not the hard part.
Okay, ma'am.
Okay, so I think we can wind up.
Okay, ma'am. Thank you so much. It was a very informative and effective section we have now, and we have the right base for our coming sessions. And she has explained everything in detail, and we have that base for our coming section. It would have very much effective and helpful for us. And thank you so much, ma'am. And I would like to express our gratitude on behalf of CSE Department, Vimal Jyoti Engineering College. Thank you so much, ma'am.
Thank you, Namita Miss. Thank you for inviting me. Thank you, Jeetu Miss and Department of CSE for inviting me to deliver this session. I think you got some idea about the basics. And NLP, you'll have much better understanding because you'll be dealing only with text data. So the pre-processing, everything will be entirely different. So the coming sessions, you'll have a better know, I think. Thank you. Thank you all.
Okay, ma'am, thank you. And tomorrow we have a session and the tomorrow session starting from 9 a.m. onwards. And that session will be on introduction to machine learning. Sorry, introduction to natural language processing, and that session will start from 9 a.m. onwards. And thank you so much everyone, and I will share you with one Google form. You need to fill that form out. Okay, I will share it soon. Everyone, please fill this form. This is for taking the feedback for today's session. Everyone, please fill this form out. Thank you so much. Everyone, please mark this Google form for taking the feedback of today's session, and also don't forget to mark your attendance in the attendance sheet. And after that, you can leave the session, and we will meet soon and tomorrow. Okay, thank you.